So we completed and uploaded the first version of liquidrandom, the seed generation repository that we just vibe coded for synthetic data generation. Let's check it out a bit. Right, so it's published on GitHub, on my GitHub under the name liquidrandom. I also set the visibility to public. So this is all live and public. It includes the installation instructions with like a short description, liquidrandom from pip install, quick start guide, also the categories that we added, and some pseudocode as well. How it works is we have like around 300k samples already, and seed data is also hosted on this GitHub, Hugging Face link. Also, this is a fully public, and you can actually go into the dataset itself here. So it's quite nice. Yeah, you see the 340k. So it's like 35 megabytes in total. So yeah, maybe the Parquet already compressed something a bit. If you remember from the previous video, we switched from JSON-L to uncompressed to Parquet. So hopefully already some benefits there. As well as, like, as I mentioned, it's published on PyPy, so you can just pip install it. Again, like with under name pip install liquidrandom. Recommended way is not the pip directly, but a more modern version with UV, either UV add or like UV pip install. Okay, this is great. A vibe-coded repository that helps us randomizing our data generation process. But in this video, I want to extend it and add additional functionality that is not there, but desperately needed in a lot of the data generation processes that we have in practice. Specifically, I want to use functions and tools as an additional seed data category, such that when we want to generate data for synthetic agents, we have actually some wide set of sample tools, MCP servers or something that we can use in our generation process. And the reason why this is important, obviously, because agentic is the reason this is important is obvious, because agentic workflows is like the typical use case of large language models. So let's get started. We again in the repository, here the liquidrandom, it's all published, committed to GitHub and everything. So what we have also updated the cloud.md. So if you just show the cloud.md file, it has been actually modified by Cloud itself. So I asked it after we finished our last step to just update the cloud.md with the actual implementation and the discussion that we had, because we made a couple of changes in the specifications, such as, for instance, from JSON-L to Parquet, a lot of stuff with the taxonomy tree we changed. So it is also important that this has been reflected. You could manually update it, but like, why not let Cloud itself run this? Maybe that's a bit too big of a font size. Let's see, decrease it slightly. So instead of using the cloud.md, which is like for the initial commit, for the initial generation or version, fine to just include the specs there. I want to create a second markdown file, and let's just call it step 2. Step 2 of liquidrandom. In the second phase of liquidrandom, we want to add an additional seed data type in the form of MCPs, tools, and functions for agentic workflows. All right, so this is a quick description. This will be already probably enough for the model to take it. And with the previous context of the CloudMD and so on, there's a seed generation repository, there's the taxonomy tree. With this, it will already go and probably generate data, like in the edit as a category. But there are a couple of things that we want to be careful for about that. So that's why we need to actually have a longer prompt. And the first one is quite complex, I would say. It is because there are different, a tool can have different names, can have different, the same tool, same function can be implemented by differently named tools. The arguments could be slightly different structured and so on. So that's why we actually want to have additional randomization source of just the same tool, but with a different function name, with a different argument ordering, with different argument types and so on. Let's write it down. Additional randomization needed. The same function can be implemented with differently named tools or tools / functions that have different parameters, names, e.g., let's say names, formats, types, etc. So this is all still, like, most people with this sentence cannot actually make a lot of sense from it. So let's just give an example. Consider the following example. Yeah, Python code. It already, like, Copilot already added a Python or opening bracket. Let's say def, let's say search flights, origin, destination, date. Def. Look up, like flight lookup. Class from code to code. Let's say year, month, day. Let's add here also actually a return date none. Okay, so these 3 Python functions, all for searching flights. You know, the first one just origin, destination, date. It's more probably the most basic one. The next one is just differently named. It's just instead of search, by the way, there's an R missing here. Search flights, find flights. It has not origin, but origin city, destination city. It has departure date, so it's still very similar fundamentally. But it has an additional argument here. Additional argument is return date. You know, that's default none. So it's just maybe a one way or something like that, right? And another function is like flight class. It has additional class type, for instance, economy or something like that. And then we have from code to code as kind of like the 3 letters codes for like the airports or something, like the airport code. I don't know how it's actually named. And then also the date, we have year, month, and day. So separate arguments. So really this is the above 3 Python function. Python functions illustrate that the same functionality but with different parameters, formats, and types can be amended. Same function can be with different parameter names. Fine, this is a common occurrence because therefore now comes actually a relevant part. We don't want to create just a single randomized, it's just a single function for each tool, but rather we want to create a more. No, it is not what. Instead of like, this is actually complex. So instead of creating a single function for each tool or for each tool, this is not necessary. We want to create m tools for each tool that differ in a similar fashion as the explanation and example above. M equals, let's make a multiple of 2, so 16. So a search flight, 16 different variations. That's already, I think, quite heavy. So let's maybe make it 8. 8 should be fine. 8 different variations for the same functions of search flight. A second point, so this is just additional randomization. So we don't just need one function, but multiple of them. And another one is that dependencies, dependable, or how to, a tool doesn't come alone, but usually is a set of tools or set of MCP functions that are related. So for instance, in the example above with the search flight, we want to actually, when we want to book the flight, there's also a booking flight function, right? So the question is like, how does the search flight and the book flight have an interface? So they don't come together. So like they don't come alone, basically. Groups of tools / functions. Like tools and functions do not come alone, but as a group. In the example for searching flights, we also most likely have a tool for booking flights, a tool for checking flight status, and a tool for canceling flights. Exactly, canceling flights. These tools are all related and often used together in agentic workflows. Therefore, we want to create a group of tools that are related. Can we use agentic visible parameters with a test? This is already too much context, but this is the first 2 sentences makes a lot of sense. It is important because there are dependencies between the tools. There are dependencies between the tools. E.g. the return type of the first tool is an input for the second tool, etc. Types of tools. We want to reuse the taxonomy tree from the first phase of liquidrandom, but with agentic workflows in mind. Use the web search to look for categories of MCP servers and LLM tools to create the initial root nodes for the taxonomy tree. No, that's too much already. So I mentioned in the previous video, we used the Ask User tool to kind of double check and basically do brainstorming with Cloud Code. And here we are using a different tool that's also built into Cloud Code. It's a web search tool. So I can imagine like flight booking is like an obvious example in a way, but probably it's also very cheesy or like very overused. So instead of like us looking into the web and seeing, okay, what MCPs are out there and so on, let's just do Cloud. A couple of web searches in a way. It reads the web pages way quicker than us. Maybe it doesn't get the full coverage as we have probably, but like at least decent to enough to see it in a way the taxonomy tree. We probably do not need too much depth in the tree though. I'll just add it there. E.g. 2 or 3 levels. So let Cloud handle the web search to look into the taxonomy tree and so on, and that's enough to seed it. So this gives us also like to cover like maybe vending machines. There's a vending bench I think out there and so on. There's like some coding terminal bench. Maybe it finds those things. Maybe it finds completely other areas in a way. But this is good enough. So we talked about like that we want to have like functions. Format. Actually, that's another point. Format. Use the OpenAI compatible format for tools and functions as a data model. That's good enough. It should be a data model. It shouldn't be unstructured, just a string or so, but it should be a data model. That's good enough. Then we talked about the additional randomization that we needed because we can have the same tool in different ways. The search flight with like some examples. Let's say ... to indicate that there's way more. And we want to create m equals 8. Okay. Groups of tools and functions. Tools do not come alone, but in group. So we want to group them together, like for instance, that as well. Checking. Similar to the phase 1, to phase 1. We want to also feed the output into the, again, to check the output, check for issues. That's enough context because it's already pre-done in the previous step. So it's just, also apply this here. That's enough for it. Conclusion. Just a rehearse, so make sure that you got everything right. Tools and functions, tools, MCP and functions as additional for liquidrandom. For each tool and we want to group, actually that should maybe, yeah, I want to group tools together and types of tools, yeah, web search seeding tools, seed the tree by doing web search. Use the LLM to check the output. Use the same LLM to check the output for issues. There's one context there that we probably need is like for the groups and tools like that. In order to achieve this, the LLM that generates the functions needs the previous as the input to create the, this is to ensure the variations exactly. Also, it probably makes sense to generate the group of the group first and then the variations, but this except if you strongly otherwise. So I'm not sure like whether how we'll do it, whether basically if we implemented it ourselves, whether so if we implement it ourselves, I'm not sure whether I would just generate the groups of functions, like search, booking, and sorry, flight search and booking, for instance, a group, and then create like the different variations, or a function first and then related functions on that afterwards. So I'm not sure. So I don't know exactly which one was better. So I'll let Cloud in a way, or the coding agent decide themselves. E.g., if you think that generating a single tool and then iteratively related is better, then we should go with this. Then we should go with this instead. I think that's okay. I think now we cover everything. So we have like these different tools, different things. That should be good enough. So we close this, open Cloud. We go to the planning mode, because this probably is also again very complex, different, you need to change several files, not just 2-3 files going through it, but you need to plan this ahead. So we say read at step and plan the implementation of it. Again, like if it was just a minor change, as we saw in the previous video, just like changing from JSON-L to Parquet and so on, that's not too difficult. You can just run the Cloud code directly, but in the plan mode, if it needs more sophisticated changes. So it's exploring now the pipeline, the code base. What's quite interesting here is that it uses the Cloud 4.6 Opus, but the exploring itself of the repo is done with a cheaper model. The Cloud's on at 4.6. It's not just cheaper, but also faster typically. Depends exactly on the infrastructure, also like how much batch size they run this model, hardware generation, whether they run this on the latest, like Blackwell, or like more, or like all the legacy hardware and so on. This all depends, determines the speed. So just a bigger model doesn't need to be smaller. If you run it on like with less batch size or concurrency, or on new hardware, you also get usually faster speed. So there's a lot of trade-offs with just LLM inference, and at that scale that Anthropic and these kind of big companies have. For Liquid, we don't have this problem because our models are really optimized for edge inference. So like our inference runs locally. Yeah, I'm not sure. Some of the customers actually have massive workloads, and they have the same problem actually. Yeah. Well, our partners and customers actually are doing the same thing. They also use some workloads on like new generations because they need speed and the latency there. Some of them on legacy older hardware because they have like less strict workloads that run not in real time basically. Therefore we have more flexibility and like can use slower hardware that's already like, I'll say, amortized. The cost of the capex in a way for the clusters are really amortized, and they're just using it for some money inference. Okay, great. So it's done with the planning mode. Took quite a while. Let's double check it. Context currently generates 12 categories. We want tool group. We want to generate adds tool group, blah, blah, blah. That has tool variations, taxonomy, and so on. That's great, actually. I like this. Communications. This is what he found, the root category. Communication, data, and storage level, file system, web scraping, IT health. That's great, amazing. Depth, leading. Depth 2, leading. No, I don't like this actually. I want this to let it cook for several longer time. This gives us 50-80 leaves. Something else. how many tool groups will this create in total? So I'm not sure if this is only like 50 or 80 tool groups. That's for me not diverse enough. So I really want to like get to 1,000 plus. It uses the ask user tool. It says it's 5,000 tool groups, 160 total tool variations, the right scale. Or do you want to adjust the target? 5,000 groups. Recommended. 10K groups. I think this gives us 100K variations. It should be a good starting point. We can change it anyway later. Okay, perfect. Awesome. So let's clear context, bypass permission, and let it cook. Great. So we wrote the plan in a second Markdown file to add tools, and as we saw, it's not just tool as a different seed categories, but actually categorized as tool groups of like tools that are kind of connected to each other. Searching a flight, booking a flight, canceling a flight, and then also variations, because a tool can have different naming, different parameter, ordering, and all of this stuff. So we want to add a bit more diversity there. And we wrote this plan, let it in plan mode come up with the execution of that. And now it's running the execution. It will probably take, previously in the first step, in the first phase of this video series, it took around 8 minutes or so. I assume that it will take similar time here, like maybe 5 to 10 minutes. But then overall, that should be fine. This is just implementing. Afterwards, we also have to actually run the generation process itself. And for that, probably also like what we've seen before, a day or something like that. So we'll run this overnight. Then maybe we can check in tomorrow, see how far it has come. Great. So it has completed in 4 minutes. So it's quite a bit faster than previously. It has modified a couple of files and also written some unit tests, which is great. Can you tell me the command to run this now with a batch size of 32? Okay, with this command, you can just run it. Let's open a new tab. Let's start a new tmux session. Liquidrandom. Okay, we don't have tmux installed here. Okay, let's open a new tab. Let's go into the seed generation. We source here a UV virtual environment and run the chain. Oh, what's lost? UV sync. I think we loaded the wrong environment, if I remember correctly. Yeah, let's load source. Yeah, liquidrandom. Let's see the generation. There's something interesting going on, definitely. No, there's a separate deactivate. Okay, finally. Was some issue there, like with some virtual environments, because I think I have a default installed some other, PEEP virtual environment and so on. Anyway, it's just running now. As with the previous one, we have the tree generation first. We have depth 1 and 2 only this time, which is enough. Also, we have seen in the previous step that for, I think, the creative writing or like the scientific, in one of the categories, we probably overdid it with like a depth of 3. So there was, like for the personas, for instance, it was quite nice that we had a lot of like very specificity, and because it was a structured data, it was very, we could only like load the age or load the name of the person. But if you want to add also like more detail, you could actually like use more and more attributes of the data class itself, and which is a really nice attribute from that. But in some categories we overdid. I think there was way too, it was already too detailed. I think the type of topic or the type of data, feed data that we generated here. So with this tool categories here, we definitely, let's check it out with the depth, with the taxonometry of depth 2 only. That should give us enough coverage already. So this is running now. I don't know like how long it will take. It said, Claude said before that it's around like 160K samples or so in total with different variations. So I would imagine that this will take probably a day or so. So let's just let it run and come back like tomorrow or in a couple of days and check in and see the results. All right, so we are back, and I have been running the script for a bit more than a day now, and we ran into some big issues. So let's check it out. All right, so we are back, and I have been running this script for a bit more than a day now, and I ran into some issues that you will have potentially as well. So let's check it out. So yeah, we ran the script and it did generate something successfully, around 4,381 out of the target of 5,000 samples. But if you look at the error traces, we have a lot of errors, specifically error code 403, which is kind of exceeds rate limit or something like that. Specifically, the message that we have is like that our key, the API key that we have been using with OpenRouter, basically reached its maximum monthly limit and was therefore like denied to make any successful call of an LLM. So this was happening actually very late in the process, after like 9 hours. I tried to restart it using the resume argument, because if you remember from before, it actually added a resume argument that it mentioned that we may be able to use, but it did not pick up where it left off or where the error started. So it also generated the same thing. So what I'm going to do is just basically copy paste this, including the rate limiting errors, or like the kind of key limit errors, into Claude Code to tell it to fix it. Before doing that, one thing that I want to mention that I did is to increase the rate limit. So I ran this actually to OpenRouter and increased the rate limit. I thought there was like a monthly budget limit, a couple of $100. I set it up to like 2 times that one. So let's just try to the LLM, the coding agent, with this problem, which we just copy paste basically the error message, including the trying to that it was successful, but it had these issues, and trying to resume it did not actually help it. Like, yeah, the resume argument here is like I mentioned that we can pick up. I ran into, and let's give it the context. I ran out of credits. See message above. I topped up the API key again. How can I now complete the entire 5,000 groups? Let's see what the cloud spit out, I would assume that it needs to modify a couple of things. Okay, basically modified the state.json. So let's hope it's enough. Let's go back and call again the same thing with resume. And indeed, it did seem to have picked off where it's left off and trying to finish the calls, the generation now. So it ran, so it's probably a bit more than 10% missing out of 9 hours. So probably more than an hour of runtime remaining, assuming. So I will let this run now in the background, and I'll check in one more time, hopefully for the last time, when the C data generation is completed and we can upload the data to Hugging Face and also update the PyPy package with kind of the additional C data type of the function groups that the tool groups that we just added. Great. So I will let this run. I would assume that it takes an hour or more to finish the last remaining 10 to 15% of the C data generation. And once it has completed, I will check in again, and hopefully this time everything went successfully, such that we can then upload the data to Hugging Face and update the PyPy package to now support this additional tool group C data type. Awesome. Great. So we'll let this run now. It should take a bit more than an hour or so to finish the last 10 to 15% of the remaining data. Hopefully it will finish this time successfully, or for the entire 5,000 tool groups, because I want to do the final step of actually uploading this generated seed data to Hugging Face and updating the PyPy package to also support now the tool groups as additional seed data type. Great. So we're back. The script has been running for a couple of days now, and quite successfully. Let's check it out. Great. So we see that it runs for 16,000 seconds. I'll skip the process of converting this to hours and so on. And out of the target of 5,000, we generated 6,500. So great. So more than we actually anticipated, which is, as I mentioned previously, more data is always better. Next step is, if you look at the seed data folder, we have this inspect samples script that was generated in the previous episode, because we don't, even though we have like this LLM that checks the previous output of the LLM, I don't trust it. We need to always have human in the loop checking of anything that we generate with language models or any machine learning model in general. So we'll basically go back to the cloud code and say, adapt in the seed data generation folder to be able to inspect the function, the generated tool seed data type. So it should be enough for cloud code to now like reading this file and modify it, because the seed data type has a different data model behind it and so on. It's a group, as we discussed. It's a tool group, not a normal sample, and so it needs to adjust a couple of things. But last time it was working quite well, and like the results that we observed last time was quite interesting. That certain types of seed data, and probably like the 50K or whatever we discussed with this set there as a generation target, was probably too much, or 10K or whatever we defined there. I think 10, 20K, something like that. Whereas as far as the diversity was quite sufficient. Okay, great. So it will just running this script, and that should output done with personas. So this is the personas. We ran the script last time. Personas looks quite nice. There was originally some bias that we thought that is in there, but it was just a sampling process of the inspect function that was just picking the first 10 or the last 10. They were just, I think, sorted by alphabetically ordering. So kind of all of their medical stuff was up front. So it implemented, I think, a kind of a hashing for the shard for the data for the file name to have like a more uniform distribution. Next up, we have jobs done with coding. This is a coding tasks, also quite interesting. This was actually one of the nice categories. I think if I remember math categories, they were very, very, very specific. So it's also nice, extremely specific, could be interesting for the future. The writing style, I think this is where we overdid it a bit. So you see, for instance, like the room ceiling order, containment and fear, structure, look for specific rooms. Like it's, for me, it's already too detailed. Like this is too narrow. So I think the 20K or whatever, like writing styles probably is too much. Maybe like 500 or something would be probably better in order to not explode kind of into this such detailed instructions or such detailed writing style formats. Next up, scenarios, division of stock portfolio during market crash. So I think it's just general topics, insanity, defense, legal. So this is also quite interesting. So like any situations or scenarios, hazardous material storage. This is also nice. I think I like this category. Domains, concrete. This is also very interesting. I think related to jobs. Scientific topics. This was also very, very specific. So magnetic viscosity effects in sediments with high iron content. This is extremely detailed. So this is also probably very, very diverse data that we can generate with this. Done with languages. These are also definitely overdid it here. I have no idea what al-DT camp security permitter talk is. So it's as we discussed last episode, like language was used as kind of slang or kind of terminology, like specific, like job or profession specific language terminologies actually was used here as language or interpreted as language. Also quite interesting. Reasoning patterns. Yeah, this is also interesting. I probably also overdid it here. Like this is probably too much diversity, and like therefore it's already too detailed and too specific. But overall, still interesting. Emotional states, heartbeat, echolocation. That's also like interesting. This is definitely probably for creative writing very useful. Probably instruction complexity. Also very interesting. Description, example. It was even an example. Again, hashing like recursive or whatever. Also looks very interesting for some use case there. Okay, this is tool groups. So finally we are at the tool groups. So let's scroll up. So this is actually the reason why we, sorry for the detour on like discussing the data quality on the other. We did this already last time, but not too bad to go through this multiple times. So this definitely printed a lot of tools out there. I don't know like how far we can go up there even. Like, let's scroll up faster. That was a tool. So this is probably last 10 samples. So let's, yeah, here we have the tool groups, sorry. So this is sample 1 to 5. Domain, PEP, and associates screening. So we have tools. So we have one tool, canonical name, identify PEP status. And then we have, interestingly, very, very different, like V0 to V7, because we have requested, like we have groups of tools, and then each tool has different ways to kind of shuffle the parameter around and so on. So let's see what, so this is probably like, yeah, this is the name of the function. So this was, you know, screen and assess and so on. So it was iterating several different names of the same function, and then also the parameters. You have identity data, object, PEP flag, boolean as a return type, and position title. You have the full name, birth, epoch, target, confirmation status, and held position array. Not too bad. I don't know what the star is. Like, is it a pointer or what? Or is it optional or something like that? Or non-optional? Can I ask maybe Cloud Call? What is the... How is the tool... How are the tools printed? See some star, some characters in the I already answered this, so you only need to read the output. Header fields, each tool in the green subpanel with canonical name, each variation a compact line. V0, search flies param, origin, the required parameters. So star is the required parameters. Run with the input, shows alongside cover. Okay, don't need to ask. I just need to read. Yeah. Great, so you have the canonical name, and then basically like 7 different variations on the same function, so different implementations. And yeah, here's like tool 1, 2, 3. That's quite interesting. So it always generated 3 tools. So let's ask if this is, no, here it has 4 tools. So the group is size 4 here. So it's kind of low, I would say, like 3 to 4 tools. I would assume is the lower end of the spectrum. Shouldn't be an issue in practice because we just can basically you call the seed data sampling function twice and just get 2 different groups and combine them to have like 8 or 7 different tools, and then maybe like calling this every interval in a row. Like we could basically say we want to have 20 tools. Maybe we need to sample not just a single tool group, but multiple of them to get to this diversity or to get to the real size of the tools. So it's like interesting. So it's just like maybe a shortcoming that we have like this. The tools are only like 3 or 4 tools in every group. So there's a bit bias. So it always probably assumes 4 groups if you train a model on this data. But or with data, we like that. But since we can just sample more tools groups and also discard tools, say like we sample the tool group A with 4 tools always, we just drop 2 of them, so we have 2 tools. So the model learns also to use just if he has access to only 1 tool and so on. So all of this not a big deal. It's just you need to be aware of it when in the generation process. But overall, like, yeah, going back up to the very first example, it was like adding the birth date, something like that, as an additional optional argument and so on. So here we have capture PDF conversion pipeline, prepare print layout, paper size, viewport definition, render DPI, measurement unit, context setting objects. So it's like a single object, paper standard code, instruction sequence, dim width. So it's quite not just the renaming the argument, but also the semantics behind the argument changes between the different variations of one tool. Again, like I think this is done quite nicely. Convert PDF buffer. All right, employee offboarding relocation. So one thing that I looked into the first 5 samples here is definitely for corporate setting. But again, like we did this from the taxonomy tree, tool groups, employee direction, management, physical. So it's like always maybe from that group. So it has to do maybe with the taxonomy tree. Maybe, I don't know. Next up, we have the last samples or whatever this is. Isn't there also shuffled samples? I thought it's like first 5 random 10 and then samples 1 to 5. Maybe at the end. Here we have the last samples, I don't know, assuming. Relational database management. Identify child records, both parent ID, upstream key value, gestural identifier. This looks great. Lock child records, update foreign key values, and release child locks. That could be interesting. Like one shortcoming that I see already here is basically like if you have a certain way that you, for instance, you lock the child records and it needs like a certain ID or something or a context object. You know, in group variation 1, for instance, like in the tool variation 1, but in like for tool number 4, let's check it again. Sorry, we have like tool like the lock child records in the let's say let's say V2 variation. We have a dataset identifier, a composite key validity period, hold security. So it's basically like the dataset identifier as a string. So this is basically the primary key probably of whatever this thing does. And let's look at the tool variation 2 of that one. So it's session lease as object, target scope. Interesting. Could definitely lead to cases when you shuffle these tool variations, then it results in incompatible primary keys or something. So imagine like your primary key here is called, I don't know, transaction star scope. What is this? Entity locator, for instance, as a primary key, but like in the tool variation one here is called log token or something. You know, that just the name, like it's not compatible. Like one is an ID with an integer, one is an object or whatever like that. That could be something that we need to look into. So there's also definitely limitations on that process. But for overall setting, I would say it's too bad. Yes. This is again the log child records, whatever, what have we there? Passenger profile, eligibility, validate passenger identity, check session eligibility, document set. I think they're related, maybe not too much. Or it's in protocols get trash interaction. Yeah, I think they should be fine. I think they're like anyway from the same context and from the same background. But I mentioned that the main issue might be with the primary key and so on, the incompatibility that is just named differently and so on. I mean, it makes the model more robust to also map different spaces, different semantic spaces to each other, interpolate them. But again, like it's probably it comes with limitations, definitely. Public holiday observation. Then yeah, here these are exactly 20 random. So we had like the first 5, the last 5, and we wanted to have 20 uniform from the entire distribution. Native scrolls position calibration. Get document height. Output unique calculation. Like this is great. This is exactly like get document height, calculate total page height with parameters on like this, how you render it, how you DPI from the printer and so on. It's great. This is exactly what we need actually. Calculate scroll increment. Again, might be different compatible. Like this one uses the viewport height, the other one the DPI from the printer or whatever like stuff, and so it's incompatible. Use different formats and so on. Not optimal, but like fundamentally it should. If it's used to train a model to do very well at function calling, it should be still good enough. Text liability structure. It's just decently. Feature flag consistency checks. Remote access request approval. Active projection contribution mapping. Energy management. Database migration detection. Scan diff for SQL files. No, overall I'm happy. I think the diversity there, like the variations, quite nice. That we have groups. They are very similar. They are all like the log child, and then you release it and so on. This is definitely like exactly what we needed, and not have like just randomly independent function, because it's the reason why we have tool groups and not individual tools for SSC data type is because tools are usually related. You know, you need to call one tool to get information and another one to do something else with the tool, right? To do something. Otherwise, it's very boring. It's very limited use cases. So this definitely serves the purpose of that. Comes with a couple of limitations. Number is always like 4 tools or 3 tools, you know, the tool group. This is definitely something that we need to like be aware of, and therefore like call them function multiple times until we have like 10, 20 tools, and remove some of them to not have all groups 4, you know, that it assumes like you can only have like a semantic group of 4. But it definitely needs management of that. And the last point is really like the incompatibility with arguments, like saying like one like listing and editing an object or something like that, creating new. They have different keys or different names that we didn't or that wasn't accounted for basically here. Again, not both of them, not I would say big issues, but they will lead in some situations to problems and limitations definitely. Great. How to push this to Hugging Face. So I think it's good enough. We can upload it, but when we created the update, the README, we should also include that this is actually like something, the limitation factor that we need to be aware of. Upload only. Let's copy this into the... Yeah, we see here actually the exact number of samples. I think for personas, for job, for the coding tasks and so on, it was great. I think the language, as I said, 22,000 different languages. that was definitely not the optimal decision there. But overall, like, yeah, we can fix this later. It crashed, interestingly. Cannot mix list and null values. We just copy paste this into like the... I don't want to read this. Just put it there. You should figure out what's going on there. That's exactly what coding agents are for, right? Fix examples. Uploading. Okay, can you make sure this change still works in the downstream liquid random random pip package correctly? So it changed something, it needed to reformat. I think this is in tool groups and so on as blah 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 in code as like having a nested structure and so on is always the issue, like in any like Parquet and like JSON and the conversion between them. What we need to make sure is just that it works downstream, whatever format it uses and how it's packing this stuff. Everything checks out, no change required. Okay, please update the readme.md, readme.md accordingly. Check these two things. Check the following two things. Check the following two things. And if they are actual concerns, note them accordingly in the README. README. Then we have first was that tool group are typically 4, always 4, typically are mostly size 4, sometimes 3, thus to avoid seeing a model / data generation, a trained model. You may want to sample multiple tool groups and or drop tools to achieve more diverse quantity of tools in each sample, in each generated sample. 2 was the interface, in parentheses, interface. The interface between the variations of tools within a tool group may not always be lining up 100% perfectly. EE primary key for function for tool A variation 1 be slightly differently named or semantically than tool B variation 2. This should not be a major issue for most use cases, but may lead to some inconsistency. May lead to some inconsistency in special cases, in certain cases, Please double check this. Please double check both claims first. Please double check both claims first. Nice. Great. So yeah, as I mentioned, those two things may lead to some limitation, but being aware of them already like fixes them mostly, I would say. So probably what does it do now? It does actually, claim 1 is real. It's mostly 3 and 4, not mostly 4. Let me check claim 2. Now I see both claims are clearly. Let me check the interface mismatch is real by looking at the tools A return and tool V across variations. Both claims are confirmed. Yeah. Obviously. Claim 2, 80% of cross-variant interface checks now show misalignment, interestingly. Now let me update the README. Done. Question about the misalignment. Point 2. Are variations of variation n of the tools aligned, e.g. tool A variation 1 aligns with tool B variation 1, 2, sorry. So the same variation within the group, are they aligned? I don't think so. I want to double check it with Cloud. No variations can independently do. Looking at generation code. Yes. Okay. Let's live with this for now. I think in the future we may need to reconsider certain things. Can you create a to-do or future plans remark somewhere? Probably in the README at the end. README at the end about these things, the misalignment of the tools, tool variations within the tool group. Two, some of the seed data types, e.g. especially the languages or writing styles, if I remember correctly. Which of the two were actually the issues? Let's go up. Okay, it takes too long. Let's go to the README actually. In the README, there's like this kind of collapsible stuff. Personas was good. I think the job management coding task was also great. Scenarios also good scientific writing. I think writing style. Yeah, definitely this is too much. Okay, I was correct on this. And especially the end writing style are probably too specific or over specific. E.g., there are 20k languages in the sense of terminology and slangs. Probably more ideal would be to cut this down in terms of diversity coverage to say 500 or so, and have only a single or maybe 2-layer deep. I mean, most of the seed data are fine though. E.g. jobs. Great. So we also added these future remarks into those feature improvements. So basically, this tool cross variation alignment, and then also the overly specified categories as two things that we want to do. So overall, in conclusion, what we've built the last couple of days with several iterations, because the data generation process took quite a while, so it wasn't fully done within 1 or 2 hours. The entire actual coding, active coding task probably took around that 2 hours or so mark, I would assume. But what we did so far is we have the seed data generation Python package, right, liquidrandom, that we built in episode 1. We adapted it with functions, tools, MCP servers, and so on as additional seed data type. Because tools are not independent, but usually come in groups. So for instance, if you list a database, you also need a function to update or delete or write to the database, right? Otherwise, it's very boring if you only can read from it. So tools come in group. So instead of having a tool seed data type, we have tool groups. This was one thing. So it's like tool group, like in the end effect, most of them are 3 tools. So one of the smaller limitations that we observed. And not just tool groups, but we also have tool variations, because you can basically have the same function with just different names, like the same list, records, view records, query records, query items. All of this could be the same function. So just rephrasing those functions. Additionally, arguments, the same story, where we have like the same argument, where we could have different arguments. You could have date of birth, for instance, as kind of a string with different formats. You can have year, month, and date separately. You could have all of these different variations of the same tool. So actually, we want to have variations in there. So we have we have a tool group, and that has typically 3 tools, 3 or 4 tools. And then within of these tools, we have 7 or 8 different, I think 8 variations to kind of add the diversity. So this gives us a lot of diversity. So overall, like there's like 6,000 tool groups, and a massive amount of tools and variations of that in there. So like times 8 and times 3 or something like that on average gives you like quite a lot of tools that we generated here. So that's quite useful for a lot of the data generation process that we want to do. 1 or 2 limitations that we have is like always this size 3, size 4 leads to kind of always having a tool group of 3. So that's why you need to sample multiple groups actually to have like, let's say 10 or 20 tools for a sample, which is totally fine. But one of the bigger limitations that we have, and that we actually noted down in the README, is that the interface between the different variations of the tools within a tool group might not be aligning. So for instance, list record that has maybe returns an ID, also like it's at least in the documentation, but like in the updated record, it has like a different structure or like a different name. So it's not 100% aligned, or not compatible. which is definitely a limitation in some cases. Overall, it shouldn't matter too much for most use cases. But it's definitely something that we may look into the future. So as a to-do item, as the last thing that we did in the process, we just uploaded, we manually checked the data, we uploaded data, and finally added a remark in the README that future improvements are these kind of variations. Plus a lot of the thing when we went through again the data quality check of the previously generated data, we saw the same observation as in the first episode, where jobs, coding tasks, very high diversity, very specific, exactly what we needed. But for languages and writing styles, definitely overdid the job, where like 20,000 different variations of languages interpreted as kind of terminologies for different professions and so on. So it's probably not the thing that we actually wanted. Well, and maybe in the future we should reconsider this. But it's still a good starting point for a lot of the data generation process. And as I mentioned before, like distillation and training small models with generated high synthetic, high quality, high diversity data, this is really where we can push the performance of small models in task or domain specific to a level where it rivals large language models. Awesome. See you then in the next episode.